Okay, thank you very much for joining us. This is Mongo in a nutshell presentation. I'll be doing a brief introduction in the Mongo database, talk a little bit about the background, the features it has, and the benefits, reasons to use it, as well as limitations. And then I'll do a brief introduction when it comes to some querying and talk and see how these compare with normal relational databases. That said, the first question that would come to my mind is, why Mongo? I'm already using a database. I probably spent a lot of years mastering my skill with relational databases. Why should I consider something that's not relational? Well, there are some key elements when it comes to Mongo database. One is that it is a flexible schema. Unlike relational databases, which you have to define the table and bring the columns have specific fields, etc. The structure in Mongo is a lot more flexible, and it's more akin to the data structure and object-oriented format we have programming, which we make developer friendly, and we can have multiple data formats in the same field. So it's more polymorphic database. To be the equivalent of the table, we have documents, and this is more of an object-oriented, as I mentioned previously. Data is stored in a document, and a document can itself have more documents inside it. And this is what we do, a table in a table. The drawback here on 2 points, we cannot have transactions or rollbacks when we do some sort of operation on the database, and we cannot join. We have document A and a document B, we cannot reach them as like we do in the relational database, where we join the host and the columns table together. A key differentiating element here is that MongoDB is highly stable, given that it has no transactions and does not join tables. That makes it very easy to connect multiple servers and create a big data center to host this. We can have geographically dispersed and redundant systems that store information in different parts of the world at the same time. So let's go touch briefly on what's SQL. No SQL. SQL is what we usually query when we're talking about tables and columns and relational databases. Project query language and there's an algorithm of that in the queries. In a NoSQL database, we don't have this map behind it. We can't create those expressions. And as you can see in the graph here, we simply have documents that are just stored in what is called a collection. I would like to point out that although MongoDB does not have transactions, the documents are authenticated. That is, the changes either done or and we can have write either the collection, which is a set of documents, or a document itself. This depends on the database version. Now, let's talk about scalability, and some key benefit when we're talking about Mongo. Imagine you start with a very simple server. We have a primary server is hosting server in Asia, and then we start being successful with our projects, and we need to create a means to address more users at at the same time. So we can put a secondary server in our region, and as our project grows and expands beyond our region, we can create secondary servers in other parts closer to our end users. For example, we have a secondary server in Europe and another secondary server in America. What does this mean? That mobile allows you to have a primary where data is stored, and then a lot of secondary references that provide all the support for your users who can easily access that information around the globe. The fact that MongoDB does not have, as I mentioned previously, Tasistro or joins makes it very easy to replicate this information on geographically dispersed sites. Here's a graph that illustrates this. On the left side, we have the very simple, featureless e-value stores for data, and on the right, we have the very feature-rich databases. For example, an Oracle database, a Microsoft SQL Server, Postgres, or SQL have a lot of features that create your own language, create triggers and things and whatnot inside that database. But it's very hard to synchronize all that across geographically dispersed servers. What MongoDB does is it looks for a center point, a point where the inflection is just enough that it has a good scalability and an optimum set of features. So we don't compromise too much of features, and we have a great deal of scalability. As you can see, MongoDB is placed there about on that line, where the scalability is about to go down the cliff. That's the sweet spot that engineering team MongoDB decided was the optimal for tasks ahead. So, after this brief presentation, I think there's enough marketing info and kind of community joining. Let's try to get our hands dirty and play a little bit with that bit. Mongo provides us with a really easy online tools we can jump in and test this feature. You can try it at try.mongodb.org. That's a web-based shell that interacts with us. An instance that is created at that moment you can type in the database and then go about your own business. This on screen I have a quick example of how Mongo works. Mongo stores documents in collections, and in the first command you see there's a show collections, and there is nothing there because the database is brand new, there are no collections. All we have to do is issue an insert command, which is an example. There's a DB, the handle for the database connection, .cars, we want to have cars in the database, and .insert, and then what's a JSON expression that represents the document. In that case, you have the brand, or also the dealerships in which the car is being sold, etc. And then we just press enter, and we get the right result of the enter, and insert the rows, and it's one. As you can see, we didn't have to create a table. We have to create anything. The database handles the storing, and I'm ready to issue a query command right after that. I can go to DB cars, find, and what would be the equivalent of the next command in the relational database is JSON expression in MongoDB. In this case, we just wanted to return the cars whose all is equal to focus. Once we issue that, we get the object that was stored. As you can see there, it automatically created an ID that identifies that object in the database, and then all the information follows. What can we put out a example? Documents in a Mongo database are JSON, and that's a really good concept because usually familiar with JSON. It's a common format. It's used in JavaScript or web services. And I'd like to point out as a parenthesis that there's a binary JSON called JSON. That's the actual representation that Mongo uses on the drive. The command line shell we're working with is actually a JavaScript interpreter to create small program inside the interpreter to, for example, iterate over a result set, and some math on it, whatever. So that's another concept because we already know some JavaScript, we have a head start when it comes to working with MongoDB. Like I mentioned earlier, there's a sample document. It's field name and a field value. As you can see there, as item pencil, point be a number, and type can be a string too. The queries are also done into JSON expressions. Now, what I want to highlight here, what a big difference between MongoDB and relational databases, that there's no strict format to it. So, for example, in the example below, the first row has quantity 500, which is an integer or could be a float, and the next row has quantity 2 as a string, and the third has a quantity that's also 500. So, big difference here in relation to standard SQL databases. You have to be careful what you're storing because it could be anything, and MongoDB will not complain. Now, let's look a little bit more into a complex document. In this case, let's analyze it a little bit more and understand the fields that MongoDB provides to us. All documents will always have an underscore ID field, that's its primary key, and in order to scan it unique, it must be unique if you would establish it, you said it when you create the document. We can have an independent document, and we can have arrays. For example, here the name is an also document. The name is another base that first and last term. We can store dates, for example, the birth and death date. We can have store arrays, and we can store other formats, like for example, long number. We specify the actual format that will override the default. There are some key things to point out. Underscore ID field is reserved for the primary key. You cannot use it for any other column in your, in your field document. The fields cannot start with the pencil character or dollar sign. That's reserved for special operators in MongoDB query structure. The field names cannot contain a dot character. Dot characters are used to reference documents within documents, as we'll see later. And field names obviously cannot contain the mode character. Okay, now let's go into queries. MongoDB has a classic insert, select, update, and delete functionality of SQL databases. The query parameters are data JSON, And this JSON is used to define what we're going to define, what we're going to insert, how we're going to sort, and what fields to project. You can say, I want you to define documents that abide this JSON expression. I want you to return only the columns or fields that mentioned in this JSON expression, and I want you to sort by this other JSON expression, and it enumerates the columns or criteria you want to sort by. Now, there are important things I would like to point out with MongoDB. When we are writing this, we are writing the whole document, not just the table. So if you have documents in that table, in that document, that all that gets written down into that database. And the document can exist many times. If you use the same command, it will get inserted again. There's no conflict with that for Mongo. And Mongo has a functionality called an offset, which is insert and update functionality put together, which may lead to a record. Basically, this means that if you try to update something that does not exist, you will create a record with update criteria. You have to be careful how you set embedded documents. Like I mentioned, we're writing the document. So if you're not careful with the update query, you accidentally overwrite embedded documents instead of actually updating. And MongoDB has specific methods to push and pop elements from arrays. Let's look a little bit deeper into the insert command and some of the particularities of it. As you can see in this example, after we insert the first car, I'm going to issue the DB cars_find.count. It will return the amount of cars I have in the collection, which is equal to 1. Then I issue a DB cars insert with an empty document, very valid expression in Mongo. You will insert it, and then we'll have 2 cars in the database. So you can see that that document is also a valid document in Mongo. Now let's look into select. We can do DB cars.find. Or .find with empty braces, and now we'll find all the cars because that's like find where 1. That's everything equivalent in MongoDB. And as we'll see, it's tricky when you do an update. If we try to find a car where a brand is known, we find only the empty document, which is the one which has no brand, actually. And if we try to find a car where the title is known, and remember, title is a column field we never actually find many of them. Title will actually return all the cars because all the cars have a known title. So when we be careful, we're going to issue an update message. Place this criteria: update all cars where the title is known. We may accidentally update all the cars, and that's not necessarily what we meant to do. When we do a select, you can also define what in projections we define which fields to return. In this, for example, I issued the command db.com.find year 2014, and I specified that I want as a second parameter brand defined. I say brand 1, model 1, that means that I want the query to return the brand and the model. As you can see, it returns the ID, the brand, and the model, and location and dealerships, and all the other information is left out. The ID field is always returned unless we specify it, which is the next example I put there. Corresponding year 2014, underscore ID 0, that is make the ID field, when one is included of each document, and then the return value is just JSON document with the brand and model fields. We can also find by ID, which is example below. Please remember that the ID is a special object, so if we issue the find ID equals to the string, it will return nothing. Because the ID is not a string, it's an object that is the correct statement by ID is object ID and then the string value of the ID. Please keep that in mind, like mistakenly return empty sets. So our projection aggregation in MongoDB allows to limit the field number to be returned. Like I mentioned before, the ID field is always returned unless it is specifically excluded. The dot notation is used to access embedded documents in the field. For example, if you recall, we had a set of dealership documents, which are the dealerships in which that particular model is being sold. To address the name of our dealership, we will use the dealership.name, and that would output the name of all the dealerships in which the vehicle is being sold. That's why the dot itself can be used within the name or a field. Aggregation of parameters are on the other point of this presentation, but I would like to comment that they allow us to process record and compute results, for example, sums and arrays and counts of a field. And there's more complex aggregation, and this is a pipeline that is a multi-stage, allows you to invoke different processes to code something, then add into something else until you render the final result. And the same applies for math reduce, which is a special functionality Mongo has that allows you to condense large volumes of data by applying functions. You get results and you apply out to get, and you can reduce that all that original information. Updates. I will touch on the updates because this is pretty interesting. The update format is the database handles the collection with objects, in this case cars, and the update command. Followed by the criteria of what we're going to update and how we're going to update, which is the update statement. Okay, once again, I want to point out that sending a document as an update statement causes a complete override. For example, if I did, in an example, I'm going to find the car, and it returns as you can see, the object that is the brand and all the year, and then I issue an update saying I want that car identified by such a need to have year 2015. It will update it, but when I put it again, all the information is lost and only the year remains. And the year has been replaced with 3. Why did it do this? Because it replaced the whole document identified by ID with whatever I specified in the update statement. So to actually update fields, we have to be careful to use update operators to specify what to do. In this example, we have an increment or set a field or unset a field or pop or push or pull for arrays. Let's do the update again and do it the right way. We have our, I'm going to insert again the car because I updated it. I'm going to find it and see that it's there, and then I'm going to update the year. I'm halfway through the string C dot update my object ID and I issue the set. That's that dollar symbol set year 2015, and it sets the year to 2015 and from 2014 that it used to be before. And the result, once I put it again, it says it was successfully updated. So update commands require you to specify what will be set up and implemented push to pull, and we use the dollar sign. Once again, that's what the dollar sign cannot be used for field names. Important things about the update. The document update by default only updates the first match. If you want to update many documents, you want to use the multi true to let it update. This has to do with performance issues usually. Since MongoDB is flat database, so to speak, and normally there's only one such record, and it makes no sense if we have 20 million records that once we found the first one, then the database needs to do for the other. So once it successfully updated the first one, it quits. If we think we might have more documents than we updated, we will specify multi-true, and that might have an impact in performance as we're switching for more. Mongo can observe the document. That means that if no match is found, it will be created with the specified update values. For example, I want to set the year to a document whose ID does not exist in the database, to create a document and include the only field in the document is going to be the year, because that's what I want to set. In this example, let's start a little bit. Here we update the car by its ID, and since there's nothing changed, you can see that there was a match, but nothing was upserted nor modified. Now, if we try to match a car in the year 2014, which we are not now because we're already in the year, and we want to set the discount to 0.5, then we specify that it's offset true. The result of that is that it matches no results, no documents with the year 2014. It then creates a document, that's why it says unobserved one, with a discount value of 0.5, and it ends. Okay, and the same thing happens when we try to do this. Deleting is interesting thing here. Remember that when we did the find, and we could do find and just the braces, and we'll find all the documents in a similar fashion. If we do cars, remove empty braces, and we'll delete all documents on the database. So be careful with that. And once again, the difference between relational databases and non-SQL database like ordinance and flexible schemas is that you can have any fields. So in this case, we have no records with field title, and we ask it to remove the cars whose title is null. It will remove every single car because no cars have the title field. So you gotta be very careful when you just count. This is we add an S, so we type something like remove or use 2014, and we put an extra S there, and you can have something effects, so you gotta be careful with that. And finally, the limit the amount of code we do by specifying a second parameter. For example, in this case, count on 1, which only removes 1 even if there are more matches. Now, Going to indexes, I think what great features MongoDB has. And what does an index do? As the same functionality as a relational database, it allows you to find information quickly. And similar way to relational databases for write-intensive functions, indexes are bad as they slow the insertion process. And the database must insert and update the document every time there's an insertion. On the other hand, for read-intensive functions, indexes are good because they accelerate the insertion process. In some cases, for example, and this is where projection it comes to be important. A certain query can be answered by the index alone, and that can lead to a 10 to 100-fold improvement in the performance. For example, so let's imagine this example where we're creating documents where the brand was stored and the model is not focused. If we have an index that covers both fields, brand and model, and you use the following projection, don't include the ID 0 and 1 and model 1. Mongo will only need to look at the index to respond to the query. This literally means that the database will not go to document itself, it will not even get out to the hard drive and retrieve it. It answers the query directly from the index, and this is huge, 10 to 100 times greater performance when it comes to answering your queries. What type of indexes does MongoDB handle? Well, there's obviously the primary index on the ID, and that's primary and unique. There are single field indexes, which as we implies only cover a single field. There are compounds that have multiple fields. There are multi-key to index array elements. There are geospatial index to index location, and text to have match and relevance with string queries. A hash, which is beyond the point of this conversation, this presentation, is for sharding. Sharding is a system of a mechanism to divide data among multiple servers that will be covered here. And there are properties to this. These sparse, different all those elements with field set, time to live, so you can automatically remove records after some time is expired, and unique as it implies what the technology was our. Let me go to the more interesting indexes. The ID is important to mention that it is primary and permanent index in the database. It identifies the document within the collection. And like I mentioned before, it has its own type, object type. And when we query by it, we have to make sure that when we are sending the database, it's not dependent on some string value. Indexes, geospatial. It's a very interesting functionality that MongoDB provides. I'm not sure. Geospatial allows us to create queries that will find points within an area. As this example, inside a polygon, an intersection, which is a special specified geometry. Actually, even search with a polygon within a polygon, you can have a big rectangle and a small square, and you can ask MongoDB to return all in the big rectangle, but outside the small one, and they will be able to do that using geospatial indexes. For example, in this case, you can find I want to specify what is creating the geospatial indexes. I want to find all the cars whose car location is within a polygon, and then they can create an array coordinates would be literally the coordinates of a whole area or maybe a particular area or political zone or a block, city, etc. Text input are another important, powerful function in MongoDB that I use to create text searches that go beyond the simple pattern matching and will return results with a relevance and can have specific features. For example, plurals or certain names that are strings that are not. But just showing you guys, for example, if and without an A are terms in English that are usually omitted. It also helps solve issues like car or cars, first and all that. Simplifies the query, which will make it very hard to get to. I can put that out in further expressions. Let me just, I will go back to that slide when I cover an example. For example, you could ask the database, I want the cars that are red, and it will return the cars that best. If you put the car as a single, it will still return the same result because it knows you're in all terms. And you can specify certain languages so it fits better to that language. This is important, for example, in my case, accents in Spanish something that become troublesome what English doesn't have accents, in Spanish does. So we have to tell database to handle it. When it comes to properties, like I mentioned, you can have images that are sparse. These are used for fields that are seldom available. For example, if you have 1 million documents and only 100 of them have a red field set to 1, I don't have to index all of them. I only index the 100 documents that have that field, and all the other ones are omitted. Let's remember that, once again, MongoDB is flexible schema, so you get into all actually there's even a requirement that all the cross documents have got the same field. So it makes sense that if you have few documents that have only one field, because you need to index 999,900 of them just for those documents. That would make the index unnecessarily large and not consumes RAM on the server, and it's not a good thing. It can be omitted by using sparse index. Time to live, if we're data collecting, and for example, we're measuring resource depletion, we're going to have a lot of data for a period of time that we want to delete it automatically. You can say, hey, we want to collect the records for a week and give it a lifetime in seconds. That would be 4,000, whatever. You do the math and specify the amount of seconds you want it to live, and the database will handle the deletion automatically. And that's big time saver. You have to go back and create scripts or data key algorithms for that. Overview. To finish up the presentation. MongoDB is a great database for large data sets that require a lot of reads, like I mentioned before, for a lot of data that needs to be replicated to rapidly dispersed areas. MongoDB is great to write points and then read many points all over the world. It is very flexible for the programmer as the data structure resembles object-oriented programming. We do a lot in modern day languages, and contrary to relational database systems which are not object-oriented. MongoDB is great with redundancy, backups, and high performance on cheap hardware, since we can have a lot of very cheap servers. We can have a lot of performance provided by a lot of servers instead of having one very high RAM, very high disk, expensive server. When is MongoDB not the best that choice? Well, maybe when you have a lot of writing intensive applications, especially dealing with money and recurring transactions. If you do a bank system, maybe MongoDB is not your thing because you want to be able to lock tables, update claim because for doing invoicing, and then that all before it goes well, you stick with that. If something fails, you want to roll back. You can't do that with MongoDB, so it's definitely not the right choice for applications. But the good news is that you have to commit one database or the other. You can have a mixture, and my most recent application includes that using traditional relational databases for the money aspect or element which require transaction logging and joining, and MongoDB for the big data, and like I mentioned before, when there are few writes and a lot of reads. And that's it. Thank you very much for bringing this presentation. I hope you enjoyed it. And we'll now go to the question and answer section. Sharon, are you there?
Yeah. Thank you, Jerry, for doing your first tech talk. Yeah, we'll take questions now. So I'll ask the guys if they have questions. Nobody, you want to start?
Okay, all right. The first question I'd like to ask you is that you have mentioned the term transactions. Did you mean monetary transactions?
Yes. For example, in a relational database, you can complete a transaction, create a series of updates, and then complete the transaction, and that transaction will either go through or will not. And that transaction can affect various databases. In this case, for example, if we had the cars database, it's not a database, it's the cars collection, and let's say we had the sales collections. We have the cars on one collection and all the sales on another. In MongoDB, I can't say I want to do an operation on a document in the cars collection and an operation on the sales collection as a transaction. Either those two go through or they can roll back. That cannot be done in MongoDB.
Yeah. Okay.
So if you had something like users on one side and we have invoicing in another collection, it would be very hard to log that, perform your update, make sure it went through correctly, and then end. That cannot be done in Mongo.
Okay, I have another question for you. The presentation said that we can limit the search. Limit the remove function. So what to row one? But what if I want to delete a row or remove a row which is in the middle? Let's say we have 5 rows, and I want to remove row 3. So how can we do that?
Okay, there's also a legal, not too deeply, but there is a limit and offset parameter you can pass to the query. So after define, you can add a sort, for example, because you might have 10 elements and you want to delete the third, but it's not the same to delete the third in ascending order than in descending order, okay? Or in any order. The first order defines it, right? So you can specify an order, you can specify an offset and a limit.
Okay. The next question is in TTL, is it possible to give a minute value to TTL because the seconds value could be cumbersome to deal with?
Oh no, you have to multiply by 60. So you.
Which means we can't directly give minute values, right?
No.
Yeah. Okay, all right.
Did you use Mongoose with MongoDB? There's some of the shortcomings of MongoDB is that can be replaced to using Mongoose with MongoDB, Mongoose ORM.
Oh yeah, well, that's that's more getting into the driver, or I'm going to use it ORM, directional mapping, because MongoDB is already object oriented. But I use, for example, when it comes to Ruby and Rails, I use Mongoid and Mongo Mapper, which from what I see here is it does the same thing. You can create a model.
Yeah, I think Mongoid is similar to Mongoose for JavaScript. Like Mongoid is for Ruby, and Mongoose is for say JavaScript applications.
Like for example, you have said that in MongoDB we can have different formats for different fields, right? Different fields having different
Data types
data
for
types.
the values.
For example, in MongoDB we have different data types for different fields. We can have that. We can have that in RelationDB, right?
Right.
But using something like the Mongoose, we can have some of the flavors of relational database. For example, we can limit which fields to change, and when you limit the field changes.
Like limit the types basically, because
Oh, yeah.
sometimes, yeah.
Yeah, because the same applies with other frameworks that I interface. You declare the type of type that field is going to be correct. But once again, you're not declaring it at the database level. So, for example, if you create a model whose name field is always a string, that's great. The model will interpret it as a string. But if another application, even a thin application, somebody forks that and changes it to integer, the database will not complain.
I have one question. What would be your advice for people who are considering transferring their existing relational databases to MongoDB? How should they go about it?
Okay, first of all, I'll explain based personal experience. Well, what do you want to do with that? You know, and in my case, we have a lot of information that is really read-only, so it's ideal for MongoDB. And we also have information that has different formats. So the flexibility of the Mongo document is much better than the structured format of relational database. So we identify those two elements. I think that would be the first step. Will MongoDB work for me? For the data, I'm going to work on it. Like I mentioned, again, you're doing a lot of Python stuff, maybe MongoDB is not your stuff. Then once you have isolated that, look into what languages you're going to be working with and what kind of drivers you're going to be working with. For example, in this case, we're using MongoJS, Mongoose.js, create a sample set of data and work with it. In my experience, working with Ruby and Rails, a lot of the functionality that are available on the shell in the database is not readily available or has to do some workarounds when it comes to using your favorite language and the driver that language provides. Okay?
Yeah.
So, And then, well, finally, so the final step is actually, going and finding the hosting and then deploying and testing that as well.
So yeah, I think that was it for questions on our end. Thank you so much for doing this. I'm sure it will help a lot of people who are starting out with MongoDB. And this is just our first Tech Talk, and I'm sure we'll have Jerry in more of our Tech Talks when we do newer topics. But yeah, thank you for getting us started.
Well, thank you for your time as well, and interest, and looking forward to making this Tech Talk a great success. Hope it's the first of many. And we'll, let's say if you have any questions, feel free to call me. I'm also starting up with this MongoDB. It's been a great experience for me. And if you have any questions or anything I could give you insight in how we've migrated some of our stuff and pitfalls and problems you could have, or maybe looking into more detail how to set up a server or different types of versions that are out there for MongoDB only, and follow on this.
On that note, I'll also add that we'll make this session and also Jerry's slides and how to get in touch with him on our website. So anyone who's watching this and wants more info can look up our website when it's available. So I guess we'll conclude here for this talk. Thank you.